This video contains mainly another list of definitions that you're going to have to remember. This one is about numbers. So let's start off with the main types of number you need to know about. First one is integers. These are the normal counting numbers that you'll be used to. 1, 2, 3, 10,000, 10,057. Whole numbers, in other words. Also, it doesn't have to be positive numbers. Negative numbers count as integers as well. So there's your first one to remember. Integers. Any whole number, however big, however large, however negative, it's an integer. In between all the integers are fractions. This is one number divided by another. So 4 divided by 5 is written as 4/5, and we say 4/5. So fractions have a number at the top and a number at the bottom. The number at the top is called the numerator. The number at the bottom is called the denominator. Don't get too hung up about remembering these. Obviously, if you can, great, but just calling them the top number and the bottom number usually suffices. So those are the two principal types of number there, integers and fractions. We will look separately at decimals in another set of videos. If you know what integers, fractions and decimals are and how to work with them, you're well on your way to understanding numbers. Okay, let's move on to a couple of slightly trickier definitions. Rational numbers. A rational number is basically any number that can be written as a fraction. So the number 3, which is an integer, is rational because it can be written as 3/1. That's a fraction. It's got a top number and a bottom number. 0.8 is rational as it can be written as 4/5. Even complicated looking decimal numbers like 4.14285 and so on is rational because that can be written as 29 divided by 7. So the very fact that you can turn a number into a fraction means that it's rational. It shouldn't surprise you to find out that if there are things called rational numbers, then there are things called irrational numbers. So irrational numbers are numbers that are not rational. If you cannot write the number down as a fraction, then it's irrational. So examples are pi, which we use in the calculation of the circumference and area of circles, and pi is 3.1417 and so on. And those decimal places continue forever. And with numbers such as pi, irrational numbers, there is no repeat in the numbers that occurs. There's no pattern to the numbers. Well, no one's found one yet. So there is no way of writing pi as a fraction. Although you may have seen it approximated as 22/7 sometimes. Another example is the square root of 2. That is 14121 and so on. Again, it continues on forever. There is no repeat in that pattern, so you can't write it as a fraction. There's an interesting proof of the fact that you can't write the square root of 2 as a fraction, and you should find a link to that somewhere on this page. Worth a look to see exactly how this kind of thing is proved. Let's move on now to some other types of numbers. First of all, square numbers. A square number, sometimes called a perfect square, is an integer that is the square of an integer. So 3 times 3 is 9, 4 times 4 is 16, and so on. So if you have a number where the square root of that number is a integer, then it's a perfect square, a square number. Visually, you can represent square numbers by patterns of dots. So if you can take the number and put it into a pattern like this, you can see quite easily that it is a square number, and you can also work out what the square root is. Alongside square numbers, we have triangle numbers. First triangle number is 1, then the next one is 1 plus 2, then it's 1 plus 2 plus 3, and so on. So these numbers are equal to 1, 3, 6, 10, 15, 21, and so on. As with square numbers, this is a lot easier to show visually. So 1 is just the number 1, then the second one is 1 plus 2, which is 3, third one is 1 plus 2 plus 3 is 6, and so on. Triangle numbers may not immediately look very useful, but they are a pattern that crop up in a number of places in mathematics, so it's worth trying to remember the sequence of numbers 1, 3, 6, 10, 15, 21 and so on, and also to try and remember how that pattern is made up by adding up the numbers up to the point where you've reached. So if you're number 3 in the list, it's adding up the numbers 1, 2 and 3. Try and remember that, and it will be helpful in the future. The final one we're going to look at here is cube numbers. This is very similar to square numbers, but cube numbers are integer times integer times integer. So the easiest example is the number 1, which is 1 times 1 times 1, or 27, which is 3 times 3 times 3, and so on. As you can see there with the number 3, cubes get very big very quickly. 10 cubed, for example, is 1000. Again, it's useful to be able to look at a visual representation of cubes, and we do that, not unsurprisingly, with cubes. So a 1 times 1 cube there, then we have 2 times 2 times 2, and there's a 4 times 4 times 4. So as you can see there, we're getting quite large numbers of cubes very quickly. 64 there if we've got a 4-sided cube. So that's been a fairly swift run through numbers of different type of numbers. Rational numbers and irrational numbers, clearly they're linked to each other. Integers and fractions, again they're linked to each other. In the integers are the whole numbers and fractions fill in the spaces between them. And then we have things like square and cube numbers. So 2 times 2 is 4, 3 times 3 times 3 is 27, square and cube numbers. And also we look briefly at triangle numbers. There are many other different classifications of numbers, some of which we will touch on when we look at them in other videos. What you need to do is to start to learn these different groupings of numbers and try and remember some of the properties that the different groups of numbers have.